In this video, we are going to do problem number 33, qsort. All right, so I have it downloaded and opened up in Racket. So let's just go down here. So this is going to be a generative recursion problem. So we're going to answer these questions. So I'm going to copy and paste these and stick them up somewhere I can see them. All right, so I recommend that you guys answer these questions because it's going to help you solve the problem. So I'm going to stick that up there. I feel like it's a bit too large. Okay. All right, there we go. All right, so problem A, design qsort, which implements the quicksort algorithm as described. To qsort a list, we will first make the problem smaller by breaking it into two lists, sort them, and then put them back together. All right, so this is going to be the tree diagram that we're going to need to get used to. So here's the steps for qsort. We define the first item in the list to be the pivot. Then we create two lists, lower and higher, that filters out all the lower and higher values, lower than the pivot and greater than the pivot, and then apply the qsort algorithms on step 1 and 2 on the toCreate list until we create the lists that are empty, and then append the sorted lower list with the list containing the pivot with the sorted higher list. All right, so that's a lot. Let me just elaborate this. All right, so elaborate all those steps below. I'm gonna grab out my pen. So given this list over here, 6819372, we're going to delegate the first number. We're going to pick the first number to be the pivot, right? So that's why you see this 6 over here. And we're going to say, hey, all the numbers that are less than 6, I'm going to gather you up and put you into one list. So in this case, it's 1, 3, and 2, right? Because those are the only numbers that are less than 6, okay? And then all the numbers that are greater than 6, I'm going to gather you up and put you into another different list, which is 8, 9, and 7. And then I'm going to do the same for these lists, all right? I'm going to delegate this entire list, right? This list over here, 8, 9, 7. I'm going to say one of you guys, the first of the list is the pivot. So that's why you see this 8 here. And then I'm going to do the same recursive process. All the numbers that are less than me, I'm going to make you into one list, which is going to be less than 7. And all the numbers that are greater than me, I'm going to gather you up to another list, which is just this 9 over here, right? Like so. And then we do that yet again. So for the number 7, that's going to be the first of this list. And then that's going to be right here. And all the numbers greater than me, go gather them up. And then all the numbers less than me, gather them up. But in this case, there are none. It's just list 1. So just get 7 empty. All right? Like so. So let's do it for this list over here, right? We're going to take the first list. All the numbers that are less than me, I'm going to gather you up into one list. In this case, there are no numbers, right? 3 and 2 are greater than me. So I'm going to gather you up to another list, right? So the ones that are less than 1 is empty. So given 3 and 2, I'm going to repeat this. I'm going to take the first list, say all the numbers that are less than me, I'm going to gather you up and put you into one list. And then all the numbers that are greater than me, there are no numbers greater than 3, right? There's only 2 in this list. So I'm going to gather you up and put you in a different list, which is, in this case, just empty. And I'm going to do the same for this 2, right? All the numbers that are greater than 2, gather you up in a list. All the numbers that are less than 2, gather you up in a list. In this case, they're both empty. All right, and then we just end up with empty to empty. And it's the same for all these other cases. So if we keep doing that, we're going to eventually end up with a sorted list when we merge them together. And you can sort of see it if you read this from left to right. 1, 2, 3, 6, 7, 8, 9, right? All these 9 and then the 2 empties on the sides, right? If we read this from left to right, then we see the sorted list. So we append it all together at the end, right? So that breaks down these steps over here. You're going to have to transcribe these steps into code form, right? Now it took someone, I think the creator took 2 years to come up with a quicksort algorithm. And it's now more described in this concise manner where it's kind of easier to transcribe it into code. We don't expect you to come up with the quicksort algorithm, but we do expect you to be able to transcribe this into code form, right? And this is the steps I just explained earlier. This way of sorting is called quicksort. It is a generative recursion problem. You are not allowed to use the built-in sort functions like quicksort. So there is a quicksort built in. So quicksort, right? That is a built-in function, but don't use that, right? Use qsort because we have to define our own like so. And don't use sort either or insertion sort. And this is the section in the book that describes how to derive it if you're more interested. All right. And that is the signature. So let's write the purpose. Produces the given list but sorted. using the quicksort algorithm described above. All right, signature, purpose, stub, and I recommend you pause the video and try to do the rest on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. Now let's go over it together. So signature, purpose, stub, let's come up with some examples, some tests to really elaborate what this does. So check expect, qsort on an empty list will give us just empty. All right, so that gives us a hint already. Check expect, qsort on say the list 7. All right, just a 1 item list. What do you think this should produce? Well, the sorted version of this is just going to be list 7. All right, let's do another test here. I'm going to copy and paste this down like so. Let's say I want to sort list 7 and 5. All right, this is not sorted. I want the 5 in front of the 7, and that is now going to be a sorted list. All right, and we can do another test here where we have 3 numbers. So we'll say 8419. 8419. All right, we want this in sorted from least to greatest. So 1, 4, and then 8, 9. That is the sorted order from this list from least to greatest. All right, and you can come up with some more tests if you'd like, but this seems like good enough for now. I'm gonna run this against stub here, and we just get mismatches. So that's fine. All right, so we can actually use the generative recursion template. Right, this one over here. I know it's a little wonky, but compared to our list template, but that is what generative recursion problems are. All right, gonna rename this qsort. So everywhere we see genrecfn, gonna rename this to qsort. All right, so this is sort of the general structure of it, and I recommend you pause the video and try to do qsort on your own. I'm going to spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So what is the trivial case, right? When is this qsort most simplest? Well, when it is empty, right? The simplest version of this problem is when it is empty. So how do we solve this? Well, it's just going to be the empty. We don't have to do solving anything, right? In this, at least for this problem, this is just going to be empty, and this is just going to be empty, All right. So let's just read the, for this case, for what happens when a list is not empty, they give us the algorithm right here. So let me actually paste that in here. All right, and paste it down here. All right, and then I'm just going to transcribe this literally. Right. So define the first item in the list as the pivot. So we need to keep track of 3 things: the pivot and a lower and higher that keeps track of all the lower and higher numbers greater than and less than the pivot. So if we're keeping track of multiple variables, it kind of sounds like we need a local to do that, all right? So local, there we go. And it says here, define the first item in the list as the pivot, all right? So the first item in the list, first the P. So this should actually be LST. So I'm gonna rename that right now, actually. So LST, everywhere I see P, I'm gonna say LST, like so. All right. All right, so this, define the first item of the list to be the pivot. So you are the pivot. All right. Step number 2, create 2 lists. Lower all the values that are lower than pivot and higher all the values that are higher than the pivot of the list, right? So define lower to be all the numbers that are smaller than the pivot. So I'm gonna write smaller, LST, and then give it the pivot. And then same for higher. All right. So higher, and I'm gonna call this function larger than the pivot, larger. There we go. Apply the qsort algorithm steps 1 and 2 to the 2 created lists. All right, so this until the lists are we create are empty. All right, so this essentially is going to be append from step 4. So append, and what we want is we want to append the recursive call to qsort on these 2 lists. So this is going to be qsort on the lower list. All right, and then qsort. So this we can just delete. All right, qsort on the lower list, and then qsort on the higher list. And then the pivot goes in the middle. All right, so I'm going to jump here. All right, I got to put this in the local. There we go. like so. So we're just transcribing this algorithm straight into code form. So now this function smaller is not defined. Again, remember smaller's job is to gather up all the numbers that are smaller than the pivot. All right, so remember this example, right? So if 6 is the pivot, which is right over here, hey, all the numbers that are less than me, go and gather them up to a list, which is 1, 3, and 2, right over here. Right, and all the numbers that are greater than me, which is going to be 8, 9, and 7, gather them up to a different list. And then repeat the quicksort algorithm for those lists, right? And then do that until you append them at the last step. All right, so that's what smaller and larger are going to do. So we can define a function smaller. Smaller consumes a list. So this is a list because this is a list right here. So LST. And it takes the pivot, which is just a number, because the first of this list is a number. All right. So num. We can call this the pivot, but we'll just leave it for now. And I'm just going to write the signature for it. So smaller consumes a list of number, and then another number, and then produces a list of number. Gathers all the numbers smaller than the pivot. All right. More generally, we can say filter. Filters all the numbers smaller than the pivot. All right. So this whole thing produces a list. So we can use empty as the stub. And I recommend you pause the video and to try to do smaller on your own. And we should probably stub out larger because it's yelling at us. Define larger. All right, and we're going to do that a bit later. But anywho, pause the video and try to do smaller on your own. I'm going to go spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. Now let's go over it together. So check, expect smaller given a list of numbers. So let's say, I'm just going to write a bunch of random ones. All right, there we go. 2, and then 7. There we go. All right, so given this list, and then a pivot number, so let's just say 4, right? This means all the numbers smaller than 4, all right? So all the numbers smaller than 4 I want to keep. So 8 is bigger than 4, 3 is smaller than 4, 4 is equal to 4, so we don't want that. 9 is greater than 4, so we don't want you either. 1 is less than 4, and it is smaller than 4, the given number, so we keep that. 2 is also smaller than 4, so you're in. And then 7 is greater than 4, so you're out. All right? And we can do one example for the simple case, the base case. So smaller, given the empty list and some number, we'll say 9. It doesn't matter, right? We're given an empty list to just produce an empty list. All right, so that seems like a good set of tests here. We can run it. And it looks like we just get mismatches and some errors, but we can fix those errors. Those are related to qsort, which we'll fix shortly. But we need to do smaller and larger, these sub-functions that build quicksort first. But anyways, let's just carry on with smaller. Right, so this smaller function is a sub-problem of this generative recursion problem. All right, so let me just scroll up. I don't want to ruin this, but these questions over here. Generation. How do I generate new smaller subproblems that solves this overarching problem, right? So those are the two smaller subproblems, and then we have to combine them, right? So smaller and larger are the two smaller subproblems of this quicksort algorithm. Anyways, I recommend you pause the video and try to do smaller on your own. It's just a classic structural recursion template compared to this one, which is generative recursion, right? And I'll explain that shortly. Anywho, pause the video and try to do this on your own with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So I'm going to comment this out. This is a structural recursion problem. So we can just do the cond, check if the given list is empty. All right, if it is, we do something. Otherwise, we take the first of the list and then we do a recursive call on the rest of the list. And there we go. That's the classic structural recursion template. All right. So really pause the video. Hopefully this should be all the mental having needed to solve smaller. Again, spoilers in 3, 2, and 1. Okie dokie. So given this first test, given empty, produce empty. All right. Otherwise, we sometimes want to keep numbers that are less than 4 for this, right? And then the ones that are greater than 4, this 8, 9, 7, they're greater than me. I don't want you in this output list, all right? So sometimes we keep numbers, sometimes we don't keep numbers. We have to do some decision making. Therefore, we need an if. All right, so if the given number, the first number, each number in the list is greater than, it's less than the given number, right? This num, the pivot, essentially. Then we want to keep it. So this looks like a classic filter problem. So to keep it, we do cons and then the first of the list, the number itself, and then onto the recursive call, because we're going to keep going through the rest of the numbers. So there we go. And then this stays the same. This is when we don't keep the numbers. All right, so we run this code. All those tests do pass. All right, it's just the qsort ones that don't pass just yet, but we can go over this shortly. All right, so let's just do the one for larger than next. I'm going to actually write the signature and purpose and stuff for you guys. Larger consumes a list of number and produces, well, also a list of number and a number and produces a list of number. All right, purpose filters all the numbers greater than the given number pivot. All right, signature, purpose, stub, and I recommend you do the examples and all the other steps on your own. I'm good with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. Now let's go over it together. So it's essentially this, right? But with just this sign swapped, okay? Because this one filters all the smaller numbers, and this one filters all the bigger numbers. So instead of like 4, this one, right, given larger of 4, then we're going to get all the larger numbers in this list. All right, so let's just actually copy and paste this to save time. All right, that's what I'm going to do. All right, and then I'm going to rename this larger. Everywhere I see smaller, that's going to be larger. Larger, 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 larger. And then the purpose statement we just wrote. There we go. All right, delete this stub and delete that. All right, and then I just said that this is just the change of the sign and adjustment of this test. All right, so all the numbers larger than 4 I want to keep. So is 8 larger than 4? Yes, it is. So there we go. Is 3 larger than 4? No, you're smaller, so I don't want you. Is 4 larger than 4? No, it's equal to 4. Is 9 larger than 4? Yes, it is, so I want you. Is 1 larger than 4? No, I don't want you, because you're smaller. Is 2 larger than 4? No. Is 7 larger than 4? Yes, it is. So we want to reduce 8, 9, 7. All right, and you can write some more tests if you want to clarify what this does. All right, so now we're back to quicksort. All right, so we're going to append the pivot here, and append, we get an error here. Append expects a list given 1. Append expects a list given 5. Right, so you should really try to create the error itself, right? So we're giving it like a number. That's why it's kind of glitching out. All right, then the argument must be a list, and pivot is a number. So we got to wrap this in a list, and we get all 8 tests do pass. All right. So now test, review, and refactor. So we can actually put these functions inside this qsort function, because this smaller and larger is really only relevant inside this function, right? And we can actually rewrite this to be filter using filter. So I'm just going to do that actually. All right. So define lower is going to be the filter, lambda v is going to be all the values. I'm going to say val, and all the numbers that are less than me. So I'm going to grab this essentially. All right, this is smaller, except this first is just replaced with val. And then this num is just the pivot. So we don't have to pass the pivot, right? So this is filter the argument itself, and then the list. All right, and we do the same thing, but for higher. Control I, higher like so. This just gets changed to that. And if I run this code, same 8 tests do pass, right? These pass, these tests still pass. Right, so that's one of the ways you can abstract this function. If you can figure out that, hey, this looks like the classic filter function because we keep numbers, we keep things, and we remove things depending on some condition here. And that's how you rewrite it into using filter. All right. So yeah, by doing that, we didn't have to pass in this number. It gets it from the context of the local. All right. So that's a little more shorter. So we wouldn't have to write these functions. All right. So that is pretty much it. We had to transcribe this algorithm, this quicksort algorithm that took like 2 years or so for someone to develop it. And we had to transcribe this into code form. Define the first item to be the pivot right over here. Create two lists and gather all the smaller numbers and greater numbers than the pivot. And then apply the quicksort algorithm on it again. So qsort again, and then append them together. That was the combinator. All right. And this is generative recursion because notice that we don't qsort on the rest of the list. We qsort on the lower and higher of the list, right? So we do a recursive call to quicksort, but not on the rest of LST. Right? That's not what we're doing. We're doing it on the filter of lower and filter of higher. So it is getting smaller, right? So we can answer all these questions here. I like so, right? So it terminates because each recursive call, the list is getting smaller. The validity, I think any list of numbers is valid. Combination, they gave it to us, that's append. How do I generate new smaller subproblems that solve the overarching problem? Well, they kind of tell us, right? The two smaller subproblems you have to write is lower and higher. It's gather up the right functions that gather up the smaller and higher numbers. And the trivial case is sorting an empty list. So that's the base case, right? So again, most often than not, the generative recursion problems, they kind of just check if the list is empty or whatever the recursive type is. Most of the time they do, right? There are going to be some times where the base case is more complex, but this is not one of those cases. Anywho, that is about it for this video, and I will catch you in the next one. I recommend you submit it into Handed and check your score though. But yeah, all right. See you guys.